Hey guys, in this video we are going to talk about combining like terms, and there are two specific questions I want to address when it comes to combining like terms. The first is, how do you know what the like terms are and how do you combine them? Now these are two questions that I feel like most students, particularly those just starting out, have questions about, or even as it gets more advanced in math. How do I know the difference between the terms x squared or x cubed or y squared, So we're going to talk about that in this video. So let's go ahead and get started. So how do you know what the like terms are? Now, the basic or the most basic understanding of like terms is pretty much imagining you telling your kid or your nieces or nephew as a baby to put all of the red items on one table and the yellow items on the other, or to show you what all of the purple fruit or the green fruit. That concept is actually the same concept being applied here. So imagine then that we have a bag. My bag should be a little bit bigger than this. But imagine that we have a bag, and this bag has different shapes in them. So we have some circles in here. We have some triangles. And let's put in here some squares. Okay. Now, if I asked you to combine the like items, because terms are pretty much, you can refer to them as items if you want to. So if I told you that I want you to tell me or represent everything in this bag, but I want you to make sure that all of the like items are together, what you're going to do is you're going to reach in this bag and you're going to take out all the items and put them into piles. So you're going to put all of our blue triangles in a pile, right? And then you're going to go ahead and put our green squares, which we have two of them, in a pile, followed by, the three circles we have. And all of these items make up what's in my bag. So the sum of all of these items, because I don't just have triangles or I don't just have squares, I have all of these in my bag. All of these make up what's in my bag. And this is the same concept when we're talking about combining like terms. Now imagine for a moment that my triangles were represented using the variable x, right? Imagine we just had, 4 x's. Then you have your squares being represented with y's. And then our circles being represented with z's. Well, this is the same concept. The difference is just that we're using letters instead of using shapes and or colors. Another way you can look at this is, imagine instead of your triangles being x's, what if they were x squareds, right? Then our y's were x cubes, and our z's were just x's, pure x's, right? These are all the same concepts. So basically, our x and the power of the x is one term or one item. It represents, in this case, like one triangle. The x cubed itself, that's an entire item that represents maybe a whole square. So like in this case, a whole actual like shape square. And then you have your x's to the power of 1. They represent our circles in the bag. So basically, when we ask about how you know what the like terms are, especially when you're dealing with the same letter, x to the power of 2, x to the power of 3, x to the power of 1, all of those are considered individual terms. And so that's how you're going to know what the like terms are. And it doesn't matter whether it has subtraction in front of it, and we're going to look at that in the next slide. But once you see x, you know that all the x's need to go in the same pile. Now, here we ask, how do you combine them? Okay. Now, this is mostly a question when it comes to there being other operations other than addition in the problem, but let's look at both, where there is just addition and then where there is another operation in play. So imagine, and we're working with where we have x's as the base and then a different power, okay? So imagine we have x squared plus x cubed plus x squared plus x cubed plus x cubed plus x squared. Okay, now that's long, but it's not that bad. So the first thing, remember, we're imagining our x to the power of whatever as one item. So the first thing we're going to look at is the first term in this expression is x squared. So when it says how do I combine them, I look throughout the entire expression, or if you are given an equation, you look throughout the entire thing and see where are all of my x squareds. Well, I have x squared here, I have another one here, and I have another one here. Now, I want you to keep in mind that the sign, which is the plus, that's in front of the x squareds, the sign that's in front of your term goes with the term, okay? So what I'm saying is we're adding. We see addition in front of all of our terms, so we are adding. So in this case, we have 3 x squareds, okay? And I want you to imagine that the x squared is almost like a triangle, okay? So in other words, we have 3 triangles, but instead of the shape of a triangle, we have x squared is the actual triangle, okay? So x squared is the same as a triangle. So we have 3 of those, okay? So x squared is the actual item in the bag. Then we add on to that, we're going to look at the other term. The other term is x cubed, okay? So I'm going to look and see how many x cubes do I have in my expression. Well, I have 1, 2, and I have 3 x cubes as well. And in front of each of my x cubes, we know that they are positive x cubes, or they are being added together. So I have 3 x cubes. And remember, our x cubes is as though, we have squares. Okay, now this might not be consistent with the previous slide, but the point is that x cubed is the item itself in the bag, okay? And then finally, our x's, we're going to look at that. We have 1 x here. I'm going to use green. And we have 1 here, and they are being added because there's subtraction in front of the x's. So we are left with 2 x's, and our x's are as though we have, circles. So there's 2 circles in this bag that we're talking about. Now, let's go ahead and look at when there is perhaps subtraction involved. Okay, so this is our first problem, and this is going to be our second one. And so let's go ahead and look at this for a moment. Let's say you end up with 4x squared plus 2x minus an x squared plus a x, or plus a 3x, minus, let's say we did 4x cubed plus x plus 3x cubed. Okay, so I definitely just made that up, but the concept is still the same. Now, what we're going to do is we look at every single term, okay, or every single variable or item in our bag, okay? So what we're looking at was we see that we have some x squares in the bag, we have some x's, and we have some x cubes in the bag, okay? These are as though we have, as follows in the previous question, triangles, circles, and squares. Okay, so let's not get confused, wondering, oh, is the x by itself, is the cube by itself? No, that's one individual item. So let's keep going. Let's look at all of the x squared terms. 4x squared is here, and there's also a minus x squared. Now keep in mind the sign that's in front of the item goes with the item. So what this is saying is I have 4 x squared terms, and I am going to take away one of those x squared terms. So if I took away one of those x squared terms, and I'm left with 3 x squares. Okay? Remember, it's as though I have a triangle. Okay? So instead of saying 4x squared, let's say I said I have 4 triangles and I'm subtracting 1 triangle. Well, 4 triangles minus 1 triangle is going to be 3 triangles. And so instead of a triangle, we know that our triangle is represented by x squared. All right, let's keep going. Our next item is going to be the x's. So we look at the 2x. We have a plus 3x here. And we have another plus x, right? And that's all of our terms with x to the power of 1. And so we're going to combine those as well. So we have a 2x, a positive 2x. So we have 2 circles. We're going to add to that another 3 circles. So that's 5 circles. And we add to that another circle, which is going to be 6 circles. So plus 6 circles. And if you look at our map on the right-hand side, our circles actually represent the x, okay? So we have 6 x's. And then finally, let's go ahead and look at the x cubed terms, okay? So we have a minus 4x cubed, and we're adding to that 3x cubed. Now, this is where sometimes students do get a little bit confused, and so I'm going to try to help you to understand, okay? When you see a minus in front, it's almost as if you owe someone 4, and in this case, our x cubed term is represented by a square. It's almost as if you owe someone 4 squares, okay? But it also it says to add 3 x cubed or 3 squares. So if I owed you 4 squares and I added 3 squares, then how many squares are left, or how many squares do I still owe? Well, I still owe you 1 square. So technically, I'm in the negative. So you'll end up with negative 1 square. Okay? So in our bag, we're still lacking, in other words, we're still lacking a square that we have to replenish. So negative 4x cubed plus 3x cubed is going to be a negative x cubed, or negative 1x cubed, if that helps, okay? So when I simplify, I'm going to end up with 3x squared in my bag plus 6x's in my bag. And then notice the plus negative 1x cubed. That is going to just simplify to the fact that I am lacking, right? I'm lacking negative an x cubed, or I'm lacking a square from my bag. And so that is how I would combine that if I have negatives involved. And what I want you to look out for is another video coming that will help us when it comes to combining positive and negative numbers. And that video is going to be under the numbers section. So definitely look out for that.